All right, guys, welcome to 3.12 Practice Problems Part 2. You might notice that I have a unit circle here. The previous video, all the examples, the angles were not on the unit circle, but all of these examples are. So at this time, I might suggest getting out your unit circle plate because I'm sure the colors might help some of you see things more quickly than looking at the unit circle I have here. So please get it out at this time if you are interested in using it. As you're doing so, I would like again to remind you about the restrictions for the inverse functions. The more I say it, I think the more that'll sink in. Remember that the range of arc sine or inverse sine is between negative pi over 2 or pi over 2, or restricted between quadrants 1 and 4. In a similar way, arc tangent is restricted between negative pi over 2 and pi over 2, or quadrants 1 and 4 as well. The different one is arc cosine, where the range is restricted between 0 and pi, which is quadrants 1 and 2. The domain of arc sine and arc cosine have to be between negative 1 and 1, but arc tangent has no restriction. So all of this can apply to the unit circle as well. So if we looked at the first example of arc cosine of 0, remember, arc cosine, you're plugging in a ratio and getting at an angle. So we're looking for an angle where the cosine or the x values are 0. So let me look. Where the x values are 0, here and here. Now we have two answers technically, but if we think about the restriction on the arc cosine, your answer has to be between quadrants 1 and 2. So between these two answers, this is the one that's between quadrants 1 and 2, so my answer would be, in radians, pi over 2. Let me erase the unit circle here. The next example, arc sine of 0. So this time, we are plugging in a ratio of 0 and looking for an angle where the sine, or the y value, is 0. Again, we have two places for that. We have y is 0 here, we have y is 0 here at pi. However, if arc sine is restricted, or the range is restricted between quadrants 1 and 4, this is the value that makes more sense in the situation. So that means that the angle would be 0. Not 2 pi, because remember 0 and 2 pi are coterminal, so we're going to take the first one of 0. The third example, arc tangent of negative 1. What I'm going to rewrite here is anytime you deal with tangent on your unit circle plate, I would definitely make sure you have these three things written. The ratio for tangent at pi over 6 is root 3 over 3. The ratio for tangent is 1 at pi over 4. And pi over 3, the ratio is root 3. So I know that tangent is negative in quadrants 2 and 4. And I know that the ratio of 1 for tangent is at a pi over 4 angle. So right now, I'm thinking, what angle is the ratio negative 1? Well, here, the ratio would be negative 1 because tangent's negative. And here, the ratio would be negative 1 because negative root 2 divided by positive root 2 over 2 is 1. Only one of these is in the restrictions, however. Arc tangent is restricted between quadrants 1 and 4. So this is the answer I'm looking for. So according to the unit circle, again, let me erase this for a minute. According to the unit circle, the answer on the unit circle is 7 pi over 4. However, 7 pi over 4 is not between negative pi over 2 and pi over 2. So is there another way we could write 7 pi over 4? Well, let me draw the terminal side and let me draw the angle. To get 7 pi over 4, what you're really doing is going counterclockwise. But if you considered going clockwise instead from here, instead of 7 pi over 4, this is the first pi over 4 you reach going clockwise. So that would mean that you're going negative pi over 4. So my answer with the restrictions would be negative pi over 4. And yes, these mean the same position, but this is within your restrictions. The next example, again, let me erase this just to make sure everything's clear here. Keep those tangent values. Arc cosine of negative 1/2. So my ratio is negative 1/2, and I'm thinking x values because of cosine. Where are the x values negative 1/2? Here and here in the second and third quadrant, which makes sense because that's where x is negative. However, the angle is restricted for our cosine between 0 and pi, or in quadrants 1 and 2. So this is the only angle that works with the restriction, so my answer would be 2 pi over 3. And 2 pi over 3 is between negative pi over 2 and, 2 pi over 3 is in the restriction from 0 to pi, so we do not have a problem like the previous example. The next example, the inverse sine of root 2 over 2. The ratio is root 2 over 2, and we're thinking y values because of sine. What angle or angles is the y value positive root 2 over 2? Well, positive root 2 over 2 here, as well as right here. Which one of these two is in the restrictions for arc sine? Well, quadrants 1 and 4, seems like this one is in the restrictions. So my answer would be just pi over 4. So now we're looking at the inverse tangent of negative root 3 over 3. And if we think about what angle or angles, the ratio is root 3 over 3, it would be any 30-based angle. So it would be 30 degrees, 150 degrees, 330 degrees, or 210 degrees. But tangent is negative in quadrants 1 and 2. So the 30-based angles in those quadrants are 5 pi over 6 and 11 pi over 6 here. Sorry, I had to look at that visually for a second. So between these two possibilities, again, what you're saying is the ratio is negative root 3 over 3. Which angles does this exist? Well, 5 pi over 6 and 11 pi over 6. Which one of these is in the restrictions of arctangent? In quadrants 1 and 4, it seems like this angle is the one that was going to do. So I'm going to write down 11 pi over 6. However, like the example right above it, 11 pi over 6 is not in the restrictions between negative pi over 2 and pi over 2. So if we thought about going backwards again, from here, the x-axis down, this is the first pi over 6 angle that we are reaching, which means you could think of it, instead of 11 pi over 6, as negative pi over 6. And negative pi over 6 is within my restrictions. The last example, arc cosine of 2, actually makes me think of a good point that could help in the beginning of each of these problems, like we did on the last video. If you look at what you're plugging in of 2, is 2 in the domain from negative 1 to 1? It's not. So I'm going to write a note that's not in the domain for arc cosine. So that means that this is not possible. So this does not exist, or there is no solution. Which makes me bring up the point that it may be a good idea at the beginning of every problem to see if your values that you're plugging in are within the restriction. So I'm going to take a minute and go back and double check to see if that's correct. For arc cosine, is 0 within my restriction? Yes, it is. For arc sine, is 0 within my restriction for the domain? Yes, it is. Makes sense why we could find these answers. For arc tangent, well, there is no restriction, so that was okay. For arc cosine, is negative 1/2 between negative 1 and 1? Yes, it is. Root 2 over 2. As a decimal, if you take the square root of 2 and divide that by 2, that is really 0.707, which means yes, 0.707 is between negative 1 and 1, so that worked as well at the beginning. Is negative root 3 over 3 is really negative 0.577, so negative 0.577 is in the restriction for tangent because there really is no restriction. So all of these examples, I would say if you were doing these problems again, I would have checked if the values were in the domain first, because some of you might have noticed right away that this one is not possible because 2 is not within the domain values. So that would be really good on your practice problems tomorrow in class. Okay, so at this point, I hope more of you are starting to memorize these restrictions, or at least getting more of an idea that arc sine and arc tangent are in quadrants 1 and 4, and arc sine, or arc cosine is in quadrants 1 and 2. So yes, you'll be doing more practice with this tomorrow. Thanks, guys. See you in the next video.